we have the curiously named non-fixed layer 2 cellular and satellite ATSC30 M-ABR LTE-B. I was going to go on and see if we could actually make that list even more confusing and longer, but actually we've only got half an hour to de-encrypt all these acronyms and understand what they're all about. So hopefully I have my panel here. We've got Mark, I can see in the video. I think we have Matt Stagg as well. Matt, are you out there?
Yeah, hello.
Brilliant. Hi, Matt. How are you doing?
Good. You?
Excellent. And Jack Arkey from Verizon. Are you out there too?
I am.
Brilliant. All the technicals are working now. We're getting into the swing of things. This is a good thing. Right. So if I could just sweep along the panel and ask you each to introduce yourselves briefly. Remember, we've only got about 30 minutes, so let's keep it short and snappy. So Jack, take it away, please. Tell us a little bit about yourself and what you're up to.
Sure. So Jack Arkey, I'm program development lead at Verizon, and been with Verizon for 9 years now, and was working for some time on LTE Broadcast, which we'll be talking about in this panel. Also have been a lead architect of Verizon Digital Signage, which is a product that we have today in the enterprise workspace. It's a device that allows you to hook up your display and create digital signage projection. So we offer a whole content management suite and a device that's connected to LTE, and it also supports LTE Broadcast. So we can talk a little bit about that as the panel goes on.
Fantastic, Jack. And over to you, Matt. Matt, how are you?
I'm good. Hello, everyone, and thanks for inviting me on, Dom. Good session. I caught the second half of the session before. So yeah, Matt Stagg. I work for BT Sport, looking at their mobile strategy. That is end-to-end. So that's anything from a camera using the mobile network with bonding devices back to the studio. So remote production, now distributed production. Obviously, we've had a lot of work to do during this current situation we're in, where we've had to almost explode the gallery into different geographical areas, all the way through to the distribution side. So that's anything from how we might distribute mass content. So in a former life, I worked with Verizon actually. I was one of the co-founders of the Lte Broadcast Alliance, and Verizon and SK and Telstra. So we've worked very well on that. And then XR and VR and the next stages of fan engagement.
Fantastic. And finally, Mark, tell us a little bit about yourself and what you're up to.
I keep seeing so many musicians on the panels. I feel like I should put my harmonica up on them. But I'm Mark Mislinski. I'm with Cinemedia, the largest independent software supplier in the cable television industry and streaming media industries. And we continue on our path to be fully virtualized and cloud native. I'm very proudly focused on ATSC 3.0. We've got solutions for ATSC 3.0 on-prem deployment, cloud native deployment, combinations thereof for disaster recovery. Also for the ATSC 1.0, which must be simulcast, we have a good suite of compression products with optimized compression.
Perfect. Well, look, Mark, we're going to come back to ATSC3 a little bit later in the session because we've got a long list of acronyms to decode for the audience here. One that both Jack and Matt have mentioned, which is actually kind of personally of interest to me, so I'm going to dive straight into it. Let's talk a little bit about LTE-B in particular. From my own history, I ran a CDN that was very focused on IP multicast. Driving IP multicast adoption right through the access networks to the consumers, particularly in the sort of North Europe area and so on. And I've always been excited by the network layer scaling possibilities that multicast and multicast-like technologies bring. And when Matt in particular was introducing LTE-B to various conferences that I was attending over here in the UK, I got very excited because I thought, oh, finally, we're going to be able to really, really scale live streaming. So, Matt, Jack, I don't mind which of you jumps in first here, but can you give us a bit of an update on what's going on with LTE-B and maybe a little bit of a sort of 1 minute précis of what it is so that any audience listening
Well, Jack, I'll let you go because you actually ended up deploying it. So
we did, yeah.
I can explain what we didn't.
Sure. So the idea behind LTE Broadcast, right, is like any multicast technology, and at Verizon we call it LTE Multicast, is one-to-many push, right? So you have to have some specialized nodes in your network, a broadcast server, sort of an orchestration node that kind of provisions these streams. And then, you know, you've got a gateway node and routers, right, that have to support UDP traffic. And the idea is that you can push it down, and you push it down all the way across the air, and you've got a device middleware that is actually negotiating that traffic and then presenting it up to the client layer. So, and what's really astonishing about it over wireless is the fact that you can have multiple cells participating in that broadcast. So they are all using a sync protocol to make sure that they are all delivering that content together, and they actually amplify the signal when it's being distributed over wireless. So that's the technology in a nutshell. And at Verizon, we did deploy it. We deployed it in 2015. We used it for our IndyCar application. We used it for a number of live streaming concerts with one of our other applications that's no longer with us, Go90. So the technology works, and it works very, very well when it's provisioned correctly. But it did have challenges, and I think, Matt, you were probably, I know in prep for this panel, we were going to discuss some of those challenges and why, you know, LTE Broadcast hasn't quite gotten there. And let me just add that there are some other carriers who have internationally supported LTE Broadcast, Telstra in Australia, in Korea, in Japan, and in India. So I know that it has been used in other situations and used successfully. One of the things I think that sort of hampers LTE Broadcast is this notion that it's only for live streaming. You know, there is this other component, which is it's really just file delivery. So there are a lot of ways that you can take advantage of that in delivering files, say, overnight, a tranche of files that you want to get to, say, an edge for popular content that you know is going to be viewed, say, the next day. So I still think that there is going to be a second life for LTE Broadcast. We still have it in the network today. But you know, needless to say, 5G has become our focus, and there are a lot of technologies that there's an overlap there, and a lot of learnings that came from broadcast that I think are now being applied in 5G. And so it's going to be really interesting to see how the technology evolves, and I think there may still be a room for broadcast in the future, and I think that they're certainly looking at it in standards. So I think there still will be a broadcast play in 5G.
And Matt, you had some deployments, particularly around stadiums, didn't you, over here?
We did. So we did quite a few trials. In fact, it was we did a trial back in must have been FA Cup 2014, I think it was. So that's how far back we go with the BBC, and that was one of the interestingly, that was one of the first times that we saw some real bespoke fan engagement. It was fantastic in a stadium because you could get replays cut on EBS and sent out to everybody simultaneously over 4G. So again, it comes back to this, you know, it's not all live and linear. It's that file transfer. You try getting some of those replays to people's devices over in a stadium over 4G, and you know, it's going to be impossible. Or when they come in, the relevance is irrelevant because you've moved on in the game. So you know, I can quite happily say now that if we had about enough device support to make the business case. I mean, it really does come down to, you know, we needed it in the network for EE. All of our, it wasn't just the fact that we were then bought by BT, who had BT Sport. This was all live and popular live and linear content. And in fact, you know, it's one of those things where, you know, it's not, you know, the linear traffic. Some of those appointment to view things now come on yeah, lots of people won't have seen this, but there is a show in the UK called Love Island, love it or hate it. It was popular, and it was that linear showing of that on the mobile network was as popular as many of some of the high tier sports. So it does go to show, you know, it isn't just sport. But you know, the fundamental economics of it are you need to have enough people in the same cell, watching the same content with a device that's enabled. And we just didn't have that because of the lack of support for Apple, which is why we, again with Verizon and Telstra and SK, formed a group so that we could all go out and lobby handset manufacturers with the weight of you know, ended up with the number of operators represented 300 million consumers. So you have a weight there. But then we moved into 5G. So obviously, again, you know, you've only got a pot of money to look at what you're going to do. So the idea is we'll use 5G for enhanced broadband. That will offset any of the current problems we have with capacity in any areas. And then what we'll do is maintain, and it's very much our roadmap, is to develop 5G broadcast through however that develops, because you know, spectrum's expensive, it's finite, and you shouldn't be wasting it by sending over unicast. And it then becomes a potential augmented technology for when we get rid of terrestrial TV or DTT, should that come.
So
sorry, a bit longer than I expected. So.
No, that's fine, Matt. That's fine. So what we're sort of touching on 5G and making the sort of the backhaul networks that much more optimized and the edges that much more optimized, it sort of converges a little bit with some of the MEC challenges. And Matt, I remember we had a conversation perhaps last summer, maybe before that, where I was asking, you know, how much can we actually offload into the RAN? How much can we offload right deep into the edge? And technologies like LTE-B obviously play into that. But you made a very interesting observation, which certainly here in the UK networks, most of the towers are connected with dark fiber. And so actually capacity to the edges isn't really that much of a constraint. The issue is, as you've just mentioned, almost entirely spectrum. Is that, does that still ring true?
Yes, you know, and you know, it's sort of number one fundamental in mobile networks, which is slightly different in fixed, is you always congest. If you're going to, the first point of congestion is at the RAN with the spectrum, then backhaul. So you should never have any congestion points all the way through to your CDN. So, which is a kind of the internet edge. But our edge, when we talk about, you know, edge computing, which I'm sure we'll come on to, is at the cell site. So you know, that's just the economics of it. So then, you know, you've got to get the traffic back. Hosting content at the edge just for capacity doesn't hit that spot, because you've still got the constraint in the RAN, and also it becomes, you know, prohibitively expensive. In 5G world, it's different because, you know, you can have more processing, and you know, there's a lot more moved on now around graphics offload and things like that.
So Jack, you know, obviously Verizon has got a multitude of different network topologies to deal with, where BT may be much more UK centric and so on. I presume not all of Verizon's network runs dark fiber back to your EPC cores and your core networks. Is that correct?
That's something I'm not aware of. I'm not you know, as in touch with those network components. So you know, I don't want to give you a half an answer there.
Okay, sure. So but I assume that mobile edge compute is kind of something that you guys are investigating, or? Oh,
absolutely. Yeah. So you know, the multi-edge access compute, right? Is you know, really about taking advantage of the low latency that 5G offers, right? And I think your previous panel was alluding to this as well, that for things like AR and VR applications, absolutely that stuff has to happen on the edge, right, in order to get the kind of performance that you're looking for. You know, we've got this great group at Verizon Media, the folks from a company called Riot, that do these amazing experiences with AR. But all of that today, has had to be rendered with, local specialized computers and machineries, laptops, et cetera. And all of that is being looked at as being migrated to an edge application that could be, communicating over 5G. And we've started to demonstrate that in the lab. So it's really exciting. It's going to be really a new world for these very, very real-time experiences, very, very, impressive, immersive experiences.
And so, Mark, this kind of provides a nice point for segue. So, as the 5G networks are rolling out and they're starting to introduce, and it dates me a bit calling it mobile edge compute. I realise it should be multi-access edge compute. But as
tomato.
Exactly. Or as my kid called it, tomato the other day. But anyway, but Mark, so as we're starting to see 5G rolling out with MEC and deeper edge compute models emerging, we're also seeing something sort of arguably parallel happening, particularly in North America with ATSC30. Can you talk to us a little bit about what ATSC30 is and make sure that those who are listening in who aren't familiar have some sort of précis about what we're trying to do there?
Oh, very good. And ATSC 3.0 is a complete revolution in the broadcast industry. It's non-backward compatible with the current ATSC 1.0. It's completely full-featured and leveraging the new technology of ATSC 3.0. It's IP television in the same signal, whether it be over the air or IP fiber. It's got an IP broadband connection within it. So think of this, you have IP television in that signal, you have IP broadband with zero lag. And so on top of that, that's a broadcast network. It's over the air. It's an uncontested network into the home. It is a managed network into the home. On top of that, it's multicast. So it overcomes a number of the deficiencies, I'd say, of the CDNs. And what I'd also contest is a broadcast network just being a big stick, not having all the complexities of a cellular network. It can do IP data multicasting in certain applications more cost effectively than I think any other network out there. So there's definitely something to look at. Now, when I think about 5G, the broadcast industry definitely recognizes the need for relationships with other core network operators like the telcos and in association with 5G. But what we do know, the 5G 3GPP management layer, able to manage across different networks and a lot to do with roaming. The 3GPP management layer does recognize non-5G networks. On top of that, 5G core is built to accommodate interoperability with non-5G networks. So there are efforts in the broadcast industry to position ATSC 3.0 broadcast networks as service networks, and service networks that could be leveraged by, let's say, a 5G operator to take advantage of the cost efficiency of ATSC 3.0 for data casting, such as to Internet of Things or to vehicles. So there's definitely a melding together of 5G and ATSC, and there's definitely a benefit that ATSC 3.0 networks bring to the entire party.
So do you see the ATSC3 masts being co-located with 5G towers and there being that much of a close correlation?
I haven't really thought about the physical co-location of those. I'm just looking at the interoperability of it and the overlay of the RF transmission.
And does an ATSC3 device need a new layer 2? Some sort of lower level link chipsets or whatever built into it? Do we need to see a new technology rollout?
Well, yes, of course, you need ATSC 3.0 receivers in the televisions. Initially, there'll be ATSC 3.0 gateway devices in the home, which will do two things. One, it'll take the IP broadband portion of the signal and put it out over Wi-Fi for use by different consumers, people in the home, as well as it can knock that down to ATSC 1.0 temporarily for ATSC 1.0 televisions. But that's the thing about it. It's you enjoy all the benefits of having a layer 2 relationship with ATSC 3.0. Like I said, you've got IP television, which you can leverage the frame synchronous aspects of that. You got IP broadband with 0 lag, and so now all at once you can simulcast through the IP broadband either the same television signal or data related to the program. So now you have program synchronous applications you've just opened up, which are not available through like CDNs that have lag on the broadband side and such.
Excellent. Matt, let's just jump back to MEC for a bit. Where's MEC deployment at the moment? What's going on in the MEC world?
So we're only really, so when I say we, that's BT Sport and BT and EE, because I work across them for these technologies. We're looking at use cases in the lab. Sport is a great one, in fact, because we feel that sport use cases around AR and XR, you know, we kind of don't think of sport is really a VR type application. I mean, content, because, you know, it's not virtual reality, it's just reality, even if, you know, you might go in and out of 360 video. So the big thing that we're looking at is the extended reality, where you can start to get some of the 6 degrees of freedom. You have your multi-screen in the room. We're doing a lot of trialing with wearables. And when you come into that, you know, if you're, you know, in the lab and things like that, and Jack was sort of talking about it, you can make things work, but you've got, you know, huge compute power. And when we start to talk about wearables and where they really, you know, you can, you know, there's a stadium application, and then there's also, you know, lots of things you can do around stadiums. You can, you know, have your augmented experience. You can overlay all of the data stats about players. You can have interaction. You have polling. People can tell you where your seat is. You know, that's it. And then the other one outside of stadiums, which obviously I'm being pushed to look at more in this current environment because no one's at the stadium, is how you can bring that experience of being in the stadium into the home. And if you're going to do it on wearables, you know, sort of proper XR glasses, then you're going to have to move that compute power into the edge, because you're just, otherwise you're going to end up with, you know, very nice, cool wearables that they are coming out now. You know, companies like Nreal are doing some really nice looking, and then you've got a backpack with a load of GPUs in it. It's not quite that, but that's where we're going to go, especially as you start to look at holographic and things like that. So that's where I see it. There's also another use case which I'm looking at is in private networks. So 5G private networks, you might have some processing to say have in a stadium, you've got untethered 5G cameras for creativity because they can move, the directors have a lot. But you've also got your fixed cameras. So you may want to be able to break out at the cell site to then go into either the OB or with the fiber. Because from a stadium, if you've got fiber, you'll always use fiber from anywhere. But yeah, so that's the 2 use cases that I'm really interested in that have got legs, but also then feed across other verticals. So, I mean, BT work in lots of them, but all the things you look at for doing sort of holographics, augmented experiences, that can go across health, industry, because really all you're talking about is making an experience and providing extra detail, augmenting, if you like. And so that's where you can start to see similar things, and you can start to drive the cost down, because it does cost a lot of money to put compute and storage, or even if you don't have storage, just power and you know, electricity and things like that that they were talking about on the last panel.
Now, obviously, as we do evolve some sort of MEC strategy, while it will have an initial capital cost, obviously the ability to then dynamically roll new applications out across that mobile edge, or MEC, let's just call it MEC for the rest of the day, across that MEC platform, you know, starts to gain many of the benefits that microservices architecture and virtualization can offer, and so on. So Jack, what sort of utilization do you think Verizon will be placing on MEC, and do you think it'll change the types of video formats and the types of content delivery models that people further up the stack might be might have made available to them?
Yeah, so kind of hand in hand with the low latency that we've been talking about and was talked about in the previous panel. So there's the common media application format, right? CMAF, which is terrific. It managed to unify so that we're outputting the same content from an encoder, and then you're just describing it with different manifests, right? If that is HLS or MPEG-dash. On top of that, the standard introduced ultra low latency, right, which manages now chunks of a segment. So you've got a segmented file, but now you can actually break that segment down into tiny little chunks, right, byte ranges. And so what that means is you have players that can start to request those byte ranges from the CDN and start presenting immediately. And we've demonstrated this with this digital signage platform I was speaking of earlier. We were showing over 5G doing, playback of 4K content, 30 megabits per second at roughly around 3 seconds, but we were taking it from the cloud. So imagine if you move all that encoding and processing to a MEC environment that's right outside, say, a stadium. You will definitely start to see like 1 second and under type of latency. And we've demonstrated that in the lab with CMAF ULL. So that to me is really exciting about being able to offer true low latency delivery, and not just for a stadium environment, but anywhere, right? You could deliver that to the home if you've got the capacity to run that back to fixed wireless in the home and do the encoding, prior to getting it to the end user. So there's definitely applications like that in MEC. I think caching strategies, certainly inside our network, we can start to do some of that as well. And the VRAR that I referred to earlier. So I think there's a lot of really exciting opportunities there with MEC.
And Mark, with all these new technologies appearing and so on, particularly in the 5G space, but also in other areas of the radio spectrum space and so on. Obviously, you and I met while you were involved in the satellite industry many years ago. I wonder whether there are other layer 2 technologies that you've got your eye on that are emerging that might be disruptive or might be interesting for people in the content delivery space.
No, but what I would like to see is there's so much focus on cloud right now, and as you and I have talked about, you just can't guarantee quality of service through the cloud. So I think more needs to be taken advantage of, some of the larger telcos that have really built layer 2 from the bottom up, and that's what their networks are based on, and that's where you can have synchronous completely with any kind of edge compute on there, and almost spread layer 2 out completely like fog, to mobile edge compute. I think there needs to be more focus on it. I think clouds have their place, and there's certainly lots of applications for them, but I think we shouldn't overlook what you can do before you go into cloud, with what you can do with these wholly layer 2 networks.
I must admit, being just gently critical of certain actors in the industry, there is rather a lot being made of deep edge computing, which actually, when you look at the architecture, it is being backhauled to a cloud and then brought back out to the edge again. And I'm not sure I would call that an edge compute strategy, really.
No, I wouldn't.
The benefits. Now, I've had a question in on the chat room, and actually, if anyone has got a question would like to come in on air and ask the panel, we've got about 5 minutes left. So turn your camera on and raise your hand, and one of the other moderators will spot you and bring you to my attention. But we've had a question in the chat room from Samir, who's asking how 5G network layer, how the 5G network layers will accommodate CDN integration and what your experiences are in that space. So Matt, Jack, either both, or Mark, if you've got comments to make on that.
My son came in with our new puppy just as you asked that question, and I started without saying anything. And I've even got the background on, so it looked weirder because you couldn't see him. So you go first, Jack. I'll try and work out what the question was.
Jack, any comments about how 5G network, the 5G network layer can accommodate CDN?
Can accommodate the CDN? You know, there's something we actually haven't touched on yet, which is this idea of ABR with multicast. So I kind of wanted to go back to that a little bit, and I do see them as complementary to the CDN. So the idea behind this, right, is that you start to monitor consumption on your network at the edge, and when you start to see the same type of content being consumed by your end user, that you can actually move them gracefully over to a multicast at the edge, to a multicast, you know, UDP traffic at the edge. And so what that means is that you're actually communicating, you have a client that is on your edge that's actually communicating with the CDN and selecting the appropriate bit rate for the end users. But then you're turning that into a multicast, you know, stream at the edge, so that you have efficiency over the wireless network. It's really intriguing stuff, and it's really interesting how you can have that sort of complementary behavior between the CDN and this multicast technology.
Is that out of the labs yet, or is that still very much being trialed or prototyped?
There's a company that I'm aware of that's doing the M-ABR client architecture. So it's still kind of in an experimental phase, but I can see it being deployed pretty soon.
Yeah, some of our chaps are the really technical guys, not me, are in the research and development labs are looking at M-ABR. I think when a lot of times when people talk about content and 5G and edge, it's still in people's minds that you'll put a CDN cache on a cell site, and it really, there's more, you know, a lot more around it than that. And in fact, that's probably one of the last things you want to do, because, you know, and people say to me, oh, ultra low latency, that's fantastic for cameras, 5G cameras and getting out. But actually, you don't need really low latency for a lot of broadcasting content. Broadcasters, I'm talking about live stuff, because,
sure.
you know, if it's, say, 80 milliseconds with 4G, and even if you got it down with edge computing to 10 milliseconds, that's such a minute percentage save of what goes from a camera out to live. So it's, what we really need is to have less variance and a very stable latency. It doesn't matter if it's a bit higher. So that's very much where we're keen. But we'll see the model that CDNs use is very sound in terms of delivering content. You know, really, you're just talking about a bigger internet connection, so you can, you know, get higher resolutions as long as they carry on doing what they do. It's just behaving more like a fixed network, because, you know, you have better communication.
So
right.
Sorry,
Dom.
Yeah, Mark.
Yeah, Cinemedia, we make a full-featured CDN. We support both MPEG transport as well as OTT, as well as multicast ABR, and we build pretty much operator CDNs that make the most out of the last mile, and it can very conducive to interoperating with larger CDNs outside, including maybe something fed by a 5G network.
Now, I have just had a question, and does anyone want to comment on essential video coding? Somebody's popped a question, and Andrew Krupitska has popped in a question. Do you have any thoughts on the new MPEG video compression format called essential video coding? I have to be honest, I haven't got any thoughts because I haven't read about it myself. But is anyone on in the panel wanting to jump on that? Okay.
I can't even blame my son anymore. I just don't know what it is.
Maybe Andrew, you could update us update us publicly in the chat room a little bit more about that. That sounds intriguing. So we are hard up against the lunch break. I'm just very quickly, because it's been my sort of pet subject of the day. I'm just very quickly going to touch on power issues. So this is particularly on the 5G front, but I think it'll have bearing on the ATSC30 front as well. With this article that Tim and I wrote, which was out this week in Streaming Media Magazine, called The Greening of Streaming, We are increasingly aware of how much demand for power in the metro zone, CPE and technologies such as CPE, like mobile devices, which may not be directly connected, but they're still charging batteries at night or whatever it may be, are placing on these networks. And one of the things, particularly in 5G, I'm noticing that we're going to need a much higher density of masts and towers to deploy these higher frequency and higher power transmitter sites and so on. So if we're seeing, I don't know, a 5x increase in transmitter sites in a metro zone, that's going to be placing many gigawatts of power demand on those metro zones. And I'm just wondering if you guys have got thoughts or comments about how we can, while we try to progress the importance of performance and latency, we can also not burn a hole in the sky or planet or carbon or economy or whatever you may want to measure that against. But whether we've got tips and tricks for architects who are doing design work at the moment to make sure that we're not unnecessarily burning gigawatts for the sake of losing a few microseconds of latency.
So from my perspective, and it's probably quite naive, and I'm sure people would say it's not like that. But we do know that higher frequencies mean, as you said, more density, but it also means smaller cells. So smaller cells draw smaller power. Now, I don't know if that balances out, but it is going to be using more power because you do still have the macro layer as well. But I'm sure someone can say, but in my sort of limited view, it shouldn't get really bad because you put more cells in because people want to use that bandwidth more, and not necessarily the low latency piece. But if you had a lower frequency, so you had a bigger cell to cover more area, and also they're obviously they're bigger antenna if they're lower frequencies. So that's my view. Is maybe it's not as bad as some think.
Okay, interesting. Okay. Yeah. Oh, I had a hand up there from Mark. Mark, did you have a last comment to make?
Well, just about that. I like to think of ATSC 3.0 as kind of a happy compromise. And a lot of people don't realize that, but there are tens of thousands of towers in the United States, and a lot of them very well planted within the local communities. So to me, I think it's almost a happy compromise for an edge. On top of that, we're deploying single frequency networks along with ATSC 3.0, which means all the nooks and crannies in your basement and stuff like that all get filled with signal, and you're going to get much better reception than you do on 1.0. So something to keep an eye on.
Perfect. Okay, so I'm just going to plug, if you want to get more involved in the conversation about power in the streaming environment, do check out greeningofstreaming.org. It's a forum that Tim and I have set up just to stimulate discussion in this space, because I don't think we've had enough discussion about power efficiency. We've always been focused on performance and price. So as an industry, we're trying to stimulate a little bit more focus in that space. So please sign up and get involved. Jack, Mark, Matt, I'd like to say a huge thank you. So I'll spotlight your cameras as we go, and then I'm going to be taking us off air. So Jack, thank you very much. It's been great to have you on.
Thank you. Thanks for having me.
Likewise, Mark, it's been brilliant to see you.
Thank you, Don.
To more participation through the afternoon in the chat room. And likewise, Matt, it's been brilliant. And I'm sure you want to go and meet your new puppy, but do rejoin us once we've taken him for a walk.
Okay. Thanks very much. Good to see you.
Thank you.